All right, we're in Unit 6.6 of our Unit 6 review, and we are graphing some radical equations. Our very first question in this unit, question 24, is asking us to use the description to identify the cube root of the function g, and then it says the parent function is the square root. We did have a typo. So you can either, for this question, either answer is acceptable. If you're using the cube root, the parent function should be here. If you're using the square root, the parent function should be the square root and not the cube root. So I'm sorry for that mistake. I'm going to go ahead and use the parent function of the cube root. So the parent function is f of x equals the cube root of x. I'm sorry for that mix-up. Now what it wants us to do is write the equation with these transformations happening. So I do have a cube root in my function, and what I have to do is show certain transformations. So first and foremost, we're stretching by a factor of 4. We stretch by multiplying out in front. That's an a value. That'll go in front. We're also going to the right by 2 units. If I want to move to the right, I have to have a minus sign inside my radical. So minus 2 will move me to the right 2. And last but not least, it wants us to move down by 1 unit. So I'm going to have to put a little minus 1 at the very end for a vertical shift down 1. And that's it for question 24. Up next, we're going to take a look at how some functions have been transformed. And then we're going to have to state the domain and range. So we are actually describing how these functions have been transformed from the parent function y equals the square root x plus 1 minus 2. So let's compare our first equation 25 to this original equation. It looks like the x plus 1 and the minus 2 are the same. The only difference is this negative right in front, which means this has been reflected over the x-axis. Up next, this question is asking me to state the domain and range of my transformed graph. So it wants me to know what the domain and range of this function is. And finding the domain and range is easiest if you do a little doodle. So we're going to do a very quick doodle of what this function would look like. And we're going to do that by taking a look at how the starting point would shift and then what kind of shape it would have. So my starting point would be to the left 1 space because of that plus 1 and down 2 spaces because of that minus 2. So left 1, down 2. There's my starting point right there. And then we would draw just a quick sketch of the rest of the curve. The negative that's reflected me over the x-axis says that from here I have the bottom half of a sideways parabola. And it's just kind of going that way. I don't have to be very exact because all I'm looking for is my domain and range. My domain is all the possible x values of my function. And my x values start right here at -1 and go on to the right to infinity. Then we can look at my range. Range, it's very important. We go from left to right for domain, and we go bottom to top for range. Bottom to top, however, the bottom doesn't have any end. It keeps going down as it keeps going to the right, which means that I actually start my range at -infinity for this problem. That's the lowest point I can get to. But I do have a maximum for my range. The highest I can go is -2, and that problem's all set. Let's go ahead and take a look at how my second function has transformed from this parent function y equals the square root of x plus 1 minus 2. This one has a 2 in front. It's been multiplied by 2, and that's going to be a stretch by 2. It also has a -2 inside instead of a plus 1. So if I want to turn a plus 1 into a minus 2, I have to subtract 3. And if I subtract 3 inside my radical, I'm moving to the right 3. Last but not least, this minus 2 at the end is a minus 2 from the beginning. They match, so it hasn't been moved up and down at all. And now I would just want to do a very quick sketch of this guy so I can figure out what its domain and range would be. To find this domain and range, we're going to go ahead and take a look at what this graph would look like for its starting point. The starting point would have been moved to the right 2 spaces, and it would have been moved down 2 spaces. Let me move this number out of the way. And then it would be moved down 2 spaces right there. So that's the starting point for this function. And it's right side up, and it's been stretched out. So it's just going to kind of go up this way and make the top half of that sideways parabola. We don't have to be super exact because we're just doing that domain and range. So the domain for this guy is all the possible x values. Our x values start here and go to the right forever. So all the way from 2 to infinity. And the range is all the possible y values. And my y values go from bottom to top. They start down here at -2 and go up to infinity. So that's the lowest point, and then it's going to continue going up as it goes over. So from -2 to infinity. All right, let's go ahead and continue this on the next slide. I'm going to take this and copy it. Here we go. So our parent function is going to be right here. There we go. All right, so here's our parent function again. This is our original function. So instead of using the parent function y equals x, or square root of x, we're using this as our original function. So let's describe some of our transformations from this guy. So in question 27, we'll notice that there's no stretch or compress, there's no reflecting, but I do have a +1 in the original, and this is turned into a +4. So to turn a +1 into a +4, I must have added 3, and that would move me to the left 3 spaces. Last but not least, the number at the end used to be a -2, now it's a +1, so we must have added 3 there as well, and that would move me up 3. That's it, describing the transformation there. So let's go ahead and take a look at what our graph would look like so we can find our domain and range. For the graph, we're going to write our starting point. Our starting point has been moved to the left 4. Let me move this guy over. This guy. There we go. All right, so left 4. 1, 2, 3, 4. That's -4. And it's been moved up 3. 1, 2, 3, up 3. So this is our starting point right here for this one now. And, oh, not up 3. I'm very sorry. We're describing the transformations of the actual function itself. So I'm going to describe these ones. So left 4 is correct, and it's only going up 1 space. That one right there. There we go. So if I'm graphing, I should only be graphing this function. So I have this shape, it's right side up, it's not being stretched or anything, there we go. And my domain should be all the possible x values. The x values start over here at -4 and go to the right forever. So -4 to infinity. And then the range is all the possible y values. They start from bottom to top. So my y values start here at 1, +1, thank you, and continue up to infinity. Now we just have one question left to take a look at. This last one, if I compare it to my original function that had nothing in front of the radical, we have this 1/2, and it has been multiplied. So that's going to be a compress, because it's a fraction, by 1/2. After that, we take a look inside our radical. We had a +1 before, now we have a -3. To get from a +1 to a -3, we have to subtract 4. Thank you very much. -4, that's still an eraser, here we go. All right, and that would move us to the right 4. And very last at the end, we had a -2, now it's a +3. We must have added 5 there, which would move us up 5. Now that we've described those transformations, we're going to graph just this function so we can take a look at our domain and range. So when we graph this function, here we go. We will start by moving our starting point to the right 3 spaces and up 3 spaces, right there. And my graph is right side up, it's just a little shorter. There we go. And with this graph, we can write our domain and range. Our domain is all those possible x values, which start here at 3 and move on forever, so from 3 to infinity. And then my range will start with my lowest y value possible, which is here at 3, and move on to infinity. So from 3 to infinity. And that's it for this set of questions about graphing. Let's see. Let's go ahead and take a look at question 29 as well. All right, for question 29, we want to graph the following radical functions and then state the domain and range. This time it's a little bit more straightforward. All I have to do is figure out what transformations are happening. This one is going -2, so that's to the right 2. And that +5 means that I'm going up 5. And that's going to change my starting point. Those are the only transformations from my parent function, right 2 and up 5. So from my origin, I'm going to move right 2 and up 1, 2, 3, 4, 5, there, and that's my starting point right there. Now all I have to do is draw the rest of my function, and I'm going to use my pattern to do that. My pattern is over 1, up 1, and over 4 up 2. And unless I have any stretching or compressing or reflecting, that won't change. So in this case, it's not going to change. So from my starting point, I'm going to go over 1 and up 1. And then from my starting point again, I'm going to go over 1, 2, 3, 4, and up 2. There we go. And that's going to be it for my graph. I just have to connect these with a gentle curve and throw an arrow on the end. And that's going to be my graph. Now all I have to do is do my domain and range for this guy, which is going to start right here. My domain is all the possible x values, which start at 2 and go on forever. So we go from 2 over to infinity. And my range is all the possible y values. It'll start here at 5 and go up forever. So my range will go from 5 to infinity. There we go. All right, that problem's all set. We'll go ahead and take a look at number 30 together. Okay. So for question 30, we will again graph this guy. We'll start with describing what kind of transformations we're going to see. The 1/2 in front means that we're going to see a compress by 1/2. And then the +2 inside my radical means I'm going to be going to the left 2 spaces. And the -4 means that I'm going to be going down 4. So the left 2 and the down 4 are going to help me find my starting point. So I'm going to move left 2 and down 4 from the origin. So left 2 and down 1, 2, 3, 4. That is my starting point right there. Now all I have to do is draw the rest of my graph, and I'm going to go ahead and use my pattern to see what that's going to look like. So we have a pattern of over 1, up 1, and over 4, up 2. But I'm also compressing by 1/2. So that compressing by 1/2 means that it's going to change my pattern by changing these outputs by multiplying them by 1/2. So this is going to be my pattern. I just have to make sure to multiply my outputs by 1/2. So let's go ahead and rewrite our pattern and multiply those outputs. So we're still going to go over 1, but this time we're going to go up 1 times 1/2, which is up 1/2. And then over here we'll still go over 4, but we'll go up 2 times 1/2, which is just 1. So from my starting point, we'll go over 1 and up 1/2. And then again, from my starting point, we'll go over 1, 2, 3, 4, up 1. And now it's just like the curve I had before, but it's a little squishier. It's a little shorter. There we go. Now let's do our domain and range real fast, and we'll be all done. So the domain is all the possible x values from left to right. So it starts at, that should be a -2. Starts at -2 and goes to the right forever. And then the range is all the possible y values, starting with the lowest one and going up. So the lowest point we can get to is -4, and it goes up to infinity. All right. So we will pick up with the last 4 questions from 6.7 in the next video.